Okay, so this is the last part of the section we were going over in class today together. So this is the part of the reading problems. So we're going to go over some of this. These problems, you need to know how to work them out because they may be problems like this one on test number 3. So you need to make sure you understand this one. So this first problem says the formula A equals 23.1 times E raised to the 0.0153 times T models the population of a U.S. state A in millions T years after 2000. What was the population of the state in 2000? So see, let's identify the different variables that this formula is talking about. So the formula, okay, models the population of a U.S. state in millions. So the letter A stands for population in millions. And then it says T years after the year 2000. And I meant to put this one in a different color. It's right here. So the T is the time, and the time is being counted starting at the year 2000 and after that, right? So letter A says, what was the population? So right there, what was the population? You need to understand that what you're looking for is A, because over here A is the population. So what was the population of the state in the year 2000? So they're giving you that the T, which stands for years after 2000. See, the time is not going to be the number 2000 because over here it says on the last sentence on the problem, T years after 2000. So a number of years after the year 2000. So if I ask you how many years have passed since the year 2000 to the year 2000, 0 years, right? We're still in the same year according to what the question is asking. If this formula is calculating population starting at the year 2000 and they're asking you in the year 2000 what was the population, then 0 years have passed. So this T is measuring how many years have passed from the year 2000. And so in this case, 0 years. Every time they're asking you what's the population or what's the amount of something at the beginning of when this population or whatever the thing is being counted for or accounted for, you're always going to use a 0. When you want to refer in math to at the beginning of time of something, of the time of something, you're going to use the number 0. So then we're looking for the A. 23.1 times E is part of the formula that was given to us. It was also raised to this exponent, but now the difference is that here into the time, right here, you're going to replace the number 0. So we're multiplying this number times 0. So this dot in green that I put, it's not a decimal point, it's a multiplication symbol. So what you do is just enter all this into your calculators. So here I have my calculator, and all I'm going to do is 23.1 times E raised to 0.0153 times 0. So that's 23.1 years. Does it say to round to the nearest whole number? Doesn't say. So I'm just going to leave it as writing exactly the answer that I got. But if it would have been saying round your answer to the nearest whole year or round your answer to 1 decimal place, you just follow whatever instructions you are given. So for letter B, it says, when will the population, when will? So here what you're looking for is time, okay? So that was the answer for part A. Here what we are looking for is the time. When, it's a matter of, it's a question that is related to the time. When will the population of the state reach 28.3 million, the population. So the population is 28.3 million. So what we're gonna do is, using the same formula, that's not gonna change, we're gonna replace what we know, okay, with the given information. So we're looking for the time. I do not know what the time is, but I do know that the A over here is going to be replaced by this population. So 28.3 equals 23.1 times E raised to the 0.0153 times the time. So we want to find out, when is the time going to be that the population that was 23.1 million at the beginning is going to reach 28.3 size in the future. So first step, we want to get rid of this 23.1 that is multiplying times the E. So how do we get rid of that? We divide both sides by 23.1. So 23.1 and 23.1 on the left side, they both cancel. So we're left with this division. Let me put it in the calculator, but if it is an answer that has a lot of decimals, then let's not round. See, it's a number that has a lot of decimals. This is my suggestion to you. Do not round. Instead, I know it's going to be a little bit more complicated and challenging, but keep on using the exact answer of this division, which is leave the fraction the way that it is. Don't use decimals. When you get an answer that has a bunch of decimals like this, in these word problems, you cannot round until the very last answer. I mean, you try to round when you're dividing one number by another, and if you get a lot of decimals, it's best that you don't round this one. Let's leave it like that. So then E, because if you start rounding and rounding and rounding before the final answer at every step that you're doing, where you get a lot of decimals like this, then by the end you're going to be very off from what the actual answer should be. So then if we want to solve for the time, and the time is on an exponent, remember that we learn a property. One of the three properties that you learn in this, that you have used in this section, that you also learn in 4.3, is using the natural log, or the ln, to be able to bring down that exponent. Okay. So remember that we learned also at some point that when natural log and E are together, and when in between them there is not a plus sign or a minus sign, they both cancel each other. So then we end up here with ln of 28.3 over 23.1 equals, and then since we don't have the ln and the E on the right side, just bring down the exponent, not as an exponent anymore, but as a regular coefficient multiplying times the variable t. And if I want to find t, I'm going to divide both sides, because that's the opposite of multiplying, by the decimal. And so the time is going to be equal to dividing this fraction over here. You're going to put in the calculator natural log of 28.3 over 23.1. All this, oops, let me give myself more room. So all this divided by 0.0153. So you put it in the calculator exactly the way that you see that I'm writing it here on the screen. The natural log of 28.3 divided by 23.1, you close the parenthesis, and then you divide that by 0.0153. So that is going to be 13.3 years. Let's say, doesn't say, but let's say we round to one decimal place, 13.3 years. It's what the time would be. So make sure that when you do this into your calculator, you get the same answer as I do. If you're not, then you're probably entering things the wrong way. Okay? So that was this problem. The next one, it's going to be right here. The logistic growth function, f of t, and they give you this logistic growth function is just a formula. Okay? So this logistic growth function models or describes the population. That's what this formula describes, the population of a species of butterflies T months after they are introduced to a non-threatening habitat. How many butterflies were initially introduced to the habitat? So here is my formula. 720 divided by 1 plus 8.0 times e raised to the negative 0.13 times the time. How many butterflies were initially? Remember what I told you to refer as time being at the initial moment in the previous problem? The initial moment in math, in terms of time, we always represented with 0. So 720 divided by 1 plus 8.0 e to the negative 0.13 times 0. When you enter all this in the calculator, because you cannot enter it all at once, you're going to put a parenthesis on the denominator. And you're also going to put a parenthesis around the exponent. So you're going to enter it the following way. 720 divided by, open the parenthesis right before the 1 plus 8.0 times the e. You see how the e automatically opens a parenthesis. E raised to negative 0.13 times 0. Close the parenthesis after where you finish the exponent, which is also the 0, and then you close the parenthesis at the very end. So 80. That's the initial population of butterflies. This is how many butterflies were initially introduced to the habitat. Okay. So basically, in this kind of formulas, it looks so complicated. All you have to do is read the problem, and see what's the number that you're supposed to substitute into the t. And sometimes it's explicitly asking you, like, how many butterflies were introduced after 3 months, and then you put a 3. But here it was a question where they ask you to think a little bit more, and now you know that every time you want to refer to time in math as being the initial moment, or at the beginning of something, you use 0. So, moving on to the next question. This reading problem is going to be this one, and the next one, the one on the next slide, is going to be about compound interest. It says, find the time required for an investment. Your investments are usually going to be your present value. What you're going to start with, which in this case is an investment, you're going to start with that, it's going to be your present amount. So find the time required for an investment to grow to this much. In the future, you want this now 9,000 to grow to 21,000, and that's future value, that's represented with the letter A. I'll write the formula down right now that we're going to use. At an annual interest rate of 8%. Just keep in mind that you're always going to divide whatever percent you're given, always divided by 100. And that's what you're going to use into the formula. You're not going to plug in an 8, you're going to plug in a 0.08, because you're always supposed to divide the rate by 100 all the time. So, what's the formula we're going to use? Well, let's read the actual questions. This is the information that's given to me, and I need to find the time, but maybe there's something else that I'm missing here. So, let me do... All of these ones are the same. What changes is this word over here at the end. Yearly means 4. I'm sorry, that was for the quarterly for the next one. Yearly, how many times in the year? 1. Quarterly, how many times in the year? 4. Monthly, how many 12s are there in a year? 12. And daily, there are 365 days in a year. So 365 times. So let me do letter B, okay? Because all of the rest are the same. It's just that's the word that changes. Find the time required for an investment of $9,000 to grow to $21,000 at an annual rate of 8%. But you already know that every time in these problems that they give us the rate as 8%, we have to divide it by 100. And then it says compounded quarterly. That's your N. That's 4 times. So what's the formula that we're going to use with all this information? As soon as you read in the word problem, compounded, whatever else is the other word. As long as it doesn't say continuous, because the word continuous, compounded continuously, it's another formula. But for this one, this is the formula. Compounded daily, compounded quarterly, compounded whatever else, except that if you see the word continuous, it's a different formula. But if it doesn't say continuous, it just says compounded something else, this is the formula you're going to use for compound interest, for calculating an amount of money that is going to be earning interest, in this case, 4 times within a year. So all you need to do is substitute. I'm looking for the time, so then the A stays the same. Oh, the A is 21,000. Right? It was right here. The P, which is the present amount, it's 9,000. The 1 is part of the formula. The rate is 0.08. The N means how often within a year, it's 4 times. And then 4, it's this N and this N on the denominator, it's the same thing, times the time. We don't know what the time is going to be. The first thing that I suggest for you to do is, let's see if we can try to simplify all this inside of the parentheses. Let's put 1 plus, and I'm going to tell you, if you're using a calculator like mine, an old calculator, then you want to put parentheses around the fraction. The fraction 0.08 divided by 4. So that's 1.02. That's not a bad number to use. So you always want to simplify that first, and this is raised to the 4 times the time. So what you want to do next is 9,000 is multiplying times 1.02. So get rid of this 9,000 from here by doing the opposite operation, by dividing. So let me tell you something. If you put this into your calculator, 21,000 divided by 9,000, you may get a lot of decimals. My suggestion to you, don't use decimals. As I told you in the other problem, when you're dividing two numbers and the division yields to a decimal, a number that has a lot of decimals, don't use that. I'm going to change this as a fraction. You can use math, enter, enter, and you can use this fraction 7/3. Or let me tell you something else. If you want to reduce this fraction, you can also cancel 3 zeros from here as well as 3 zeros from here. What fraction are you going to end up with from here? You're going to end up with the fraction 21/9, which if you reduce this fraction by dividing by 3, you end up with 7/3. Isn't it the fraction 7/3, the one that we just got here? Yes, it is. So in other words, you can reduce but still keep it as a fraction, but just don't write 2.333 or write 2.3 rounding up to 1 decimal place, because that's wrong, okay? Do not round before your final answers. So I'm going to use the fraction 7/3, okay? Equals. So you could have canceled the zeros here. Going back to this, I'm going to make a little pause. You could have canceled the zeros and then reduce on your own 21 by 9 if it is reducible. Or simply put it into the calculator, 21,000 divided by 9,000. gets the decimal answer, but then click on math and then enter it twice, and it changes the fraction as a decimal, as a fraction. It's up to you. So then we have 1.02 raised to 4t. See, I'm trying to clear the space to solve for the t, but I needed to get rid of the 9,000 first. Now, the only way to make this 4t go to the front as not as an exponent, but as a regular coefficient, is going to be by putting natural log of 7 over 3, and then natural log of 1.02 raised to the 4t. And I put the natural log, remember, because that's the only property that if I have a natural log, I can bring the exponent to the front. And that's the whole purpose of this. So I keep my 7/3 equals 4 times the time times the natural log of the number 1.02. So I want to solve for the time. Well, let's divide by 4 and by the ln of 1.02. That way these two things cancel, and my time is going to be by itself, the t by itself. But remember that whatever I do on one side, I also need to do it on the other side. So we're going to enter into the calculator natural log of 7 over 3 over 4 times the natural log of 1.02. So you're going to enter all this into the calculator. Let me tell you something. On the denominator, you know, every time that we're entering fractions into the calculator and either numerator or denominator has multiple things, we want to enter it very carefully using parentheses in the correct places. So ln of 7/3 divided and opening parentheses for the denominator by 4 times ln. So 4 times the ln of 1.02, close the parenthesis of the 1.02, which is the number on the ln, close the parenthesis at the very end. So then this is 10 point, you see all those decimals. So I don't think it says anywhere to round to a certain decimal place. These are years. Let's say that we want to round to the nearest year. So this is 10.7 technically right now. Let's say that the question says round to the nearest year. That would be 11 years. Okay? So then that would be the answer. So this problem is very, very important that you know how to do it completely and that you know when to use the formula. When the reading problem is about money and it's about calculating to find the time, and it says just compounded something else, this is what it's going to be. Okay. So then, how many years on this next question? How many years? So they're already telling you they're looking for the time. Will it take for an initial investment, P, to grow to 90,000? I'm sorry. Assume the rate of rate of interest is 19%. Remember that you're always going to divide the 19 by 100. You're going to get that into the calculator when you put it. Compounded continuously. So compounded continuously. What's the formula we're going to use for this one? Every time the problem says compounded continuously, this is the formula you're going to use. If it just says compounded monthly, daily, or quarterly, or whatever as the other one, then you're not going to use this formula. You use the bigger one. But if it says the word continuously, compounded continuously, it's this one. So let's see. We're looking for the time. The present amount is 60,000. And the future amount is 90,000. The rate is 0.19, what we're going to use. You see on this formula, the letter N, it's not here. So we don't need to know how often within a year. We don't need to know if it is quarterly, monthly, that's not given here, and we don't need it. So then, in the future, we want this amount to be 90,000. And you're going to start with investing 60,000. E raised to the 0.19 times the time. So first, let's divide by 60,000. So we're trying to solve for the time that's on the exponent, and that's how we do. So here, what can we do? Let's do what I told you on the previous problem. Cancel these 4 zeros with these 4 zeros. What are you left with? This fraction is going to be 9 over 6. But reduce this fraction, divide it by 3, reduce it as much as you can so that you can work with small numbers. That's not a 2, sorry. And that's going to be 3 over 2. So then here, this fraction in simplified version is 3/2. E to the 0.19 times the time. Then the only way the exponent can come to the front is by using the natural log. So then the natural log and the E, you know, when they're together with no plus, no minus in between them, they cancel. So then we get 0.19 times the time. And then we divide both sides by 0.19 and by 0.19. So these two cancel. And the time is going to be given by ln of 3/2 divided by 0.19. Be very careful when entering this on the calculator. You don't need parentheses on the numerator or denominator because it's only one single thing on the top, one single thing on the bottom. But still, make sure you put it the way that I'm showing you. So ln of 3/2, close the parentheses, divided by 0.19, and that gives us 2.1. So I'm going to round to 2.1, and you know these are years. Let's say that the question says round to the nearest year. Well, we're going to say the nearest year is 2 years. And this would be our answer. Okay. So when do you use this formula? When it says compounded continuously. And so this is what we missed to do today in class. Okay? So make sure you are able to do these problems for section 4.5 for the homework on section 4.5, and also because some of this may be on the test. And you can see as well that as on the review that I send you for test 3, there are some questions like this one. Okay. This is all. So this was the answer.